Today we're going to be looking at graphing cubic functions. This is lesson 3.1. All right, your state standards are provided, and to be successful today you need to be able to identify and evaluate polynomial functions. You need to be able to graph a cubic function and describe the end behavior of cubic functions. Your vocabulary: polynomial is a monomial or a sum of monomials. A polynomial function is a function of the form f of x equals, and this is just in standard form, so a cannot equal 0. Okay, so it does have to have a leading coefficient with an exponent, and the exponents are all whole numbers and the coefficients are all real numbers. So here's some examples to make the polynomial functions a little bit easier to interpret if you see some examples with actual numbers. All right, so a constant function is just going to be a number. There's no variable here. So the degree is 0, and f of x equals negative 14 is an example of a constant function. A linear function is degree 1. That means you've got x to the first power is your highest exponent. Degree comes from the highest exponent. So your degree is 1, and f of x equals 5x minus 7, or y equals 5x minus 7 is an example of a linear function. A quadratic function: all quadratic functions are degree 2. That means the highest exponent is a 2, so x squared for every quadratic function is the highest degree. Here's an example: f of x equals 2x squared plus x minus 9. All right, and a cubic function, your degree is 3, and your highest exponent due to the degree is a 3. So f of x equals x cubed minus x squared plus 3x is an example of a cubic function. So a constant function, no variable. Linear, x to the first power is your highest degree. Quadratic function, x squared is your highest degree. Cubic function, x to the third power is your highest degree. All of these are considered polynomials. So even though these are all polynomials, we do have special names for them depending on what their degree is. Example 1, identifying polynomial functions. Determine whether each function is a polynomial function. If so, write it in standard form and state its degree, type, and leading coefficient. All right, if we look at A part, we have f of x equals negative 2x squared plus 5x plus 8. So we can see that the exponents go in descending order, so we know that this one is already in standard form, and its degree is 2, which means this is a quadratic function, and the leading coefficient is negative 2. And where it says type, that would be a quadratic. All right, so for A part, let's go ahead and put this down. All right, B part, negative 0.8x squared plus the square root of 2x cubed minus 12. So B part is a polynomial function, but it's not in standard form. In standard form, it has to have your highest degree first. So the square root of 2x cubed minus 0.8x squared minus 12 would put that in standard form. So that means it would be a cubic function of degree 3. Cubic means degree 3. And the leading coefficient would be the square root of 2. So let's put that down here. Moving on to C part, h of x equals negative x squared plus 7x minus 1, or to the negative 1 power, plus 4x. So because this one has a negative exponent, it is not considered a polynomial function. All right, so remember, by definition, the exponents have to be whole numbers. Whole numbers are positive, so this one is negative, so that one is not considered a polynomial function. And that's all you would do. You would say this is not a polynomial function. D part, k of x equals x squared plus 3 to the x power. All right, so this one is not a polynomial function either because this second term does not have a variable base and an exponent that is a whole number. So let's put that down. The function is not a polynomial because of 3 to the x power. All right, so remember, to be a polynomial function, you're going to have a variable raised to a power, and that power has to be a whole number. And to put it in standard form, you go from the highest degree or the highest exponents in descending order. So you go from the highest exponents down. So you can see here is 2, 1, and then this is a constant, so there's no variable. And then here we had to rearrange it, 3, 2, and no variable. These two were not polynomial functions. Example 2, evaluating a polynomial function. All right, so to evaluate a polynomial function, when it gives you x equals a number, all you have to do is take that number and substitute it in for the variable in every place you see the variable. So f of x equals 2 times 3 to the third power minus 8 times 3 squared plus 5 times 3 minus 7. So when we evaluate that, that will tell us what the function equals when x is 3. So we can just type this in, 2 times 3 raised to the third power. Make sure you bring that back down. Minus 8 times 3 squared plus 5 times 3 minus 7. So this is one of those cases where if you get everything plugged in correctly, it's easy to get the answer. So you can say f of 3 equals negative 10. So when x is 3, that was given, the output, the y value, f of x, is negative 10. All right, so take just a moment and go ahead and try to do the next one on your own. So it gives you a polynomial function, and it says x equals negative 2. So see if you can substitute negative 2 in and get your f of x value or your independent value from that. Remember, x is the independent. You can choose whatever you plug in. F of x would be the dependent. So f of x depends on what x value you put in. All right, hopefully you paused the video and took a moment to do this on your own. So we're going to have f of x equals 3 times, it says let x equal negative 2, minus 6 times negative 2 plus 10. So f of negative 2 equals, do the same thing, pull up your calculator, and we're going to have 3 times negative 2 squared minus 6 times negative 2 plus 10. All right, so f of negative 2 is 34. Example 3, describing in behavior. All right, so for a cubic function, you can see here the key idea here. If your leading coefficient is positive, all right, for a cubic function, it's always going to have this general shape, and it's going to be going down to the left, and it's going to be going up to the right. So the shape of this is because it's to the third degree, but it's also going to have opposite directions. So the in behavior goes opposite directions when it's cubic. You can see here, it goes opposite directions as well. It's just going in the opposite direction because the leading coefficient is negative. So it kind of flips it to the other side. So you can see here it's going up to the left and down to the right. So key thing to remember, the expression x with the arrow to positive infinity, you read that as x approaches positive infinity. All right, so x approaches positive infinity is how we're going to talk about the end behavior. And it's because the arrow continues. We're saying it approaches that. It never actually gets there because infinity means it continues forever. It's just kind of an idea. In math terms, it's not an actual number. It just means it continues on in that general direction. All right, so if we describe the end behavior of this, negative, so the leading coefficient, this one is in standard form, so the leading coefficient is negative. So we can say that we're going to have, it's going to be going up to the left and down to the right. So when I look at this, I always say f of x does what as x goes to the left. As x approaches negative infinity, that's the left side of your graph, right? Because this is your x-axis. And if you go to the left, that's going towards negative infinity for x. And then f of x approaches what as x goes to positive infinity. That means it's going to the right. So again, x is your horizontal axis. If you go from 0 to the right side of your graph, that is going towards positive infinity. So this basically says x going towards negative infinity as x goes to the left. What is f of x? What does your y do as x goes to the left? And then this one says as x approaches infinity, as x goes to the right, f of x approaches what? So what does your y do? So basically, your f of x, your y value, that's your vertical axis. So we're trying to see, does it go up or down? And up would be towards positive infinity, down would be towards negative infinity. What does that do in this case? So if the leading coefficient is negative, that means it's going to be this shape right here. So as it goes towards negative infinity, this is going up. So f of x would be positive infinity. And then the leading coefficient is negative. That means the other side is the opposite of whatever this is. So if this is positive, this has to be negative. And they're always going to have opposite signs here because it's cubic. And anytime it's an odd degree, the end behavior goes in opposite directions. Even goes in the same direction. All right, so describe the end behavior for 0.25x cubed minus x squared minus 1. So f of x approaches what? As x approaches negative infinity to the left. F of x approaches what? As x approaches infinity or goes to the right. All right, so when this is positive, you can see as x goes towards negative infinity, this one goes down. So this will be negative, which means this one has to be positive. All right, and these are easy to check as well. You can graph each function. All right, looking at the graph is always a good thing to do. So if you say y equals, I'm going to pause the video just a second and type this in because we're about to run out of time. All right, so if you look at the graph here, here's the equation. I typed in the equation exactly like this right here. And then I hit graph, and you can see the graph goes exactly how it says. So when it's negative, it goes up to the left and down to the right. And we would describe the end behavior like this pretty much in every case that has a leading coefficient that's negative and an odd end behavior or a cubic end behavior. Same thing with the other one. You can just type it into y equals, graph it, and you can also look to see that this is correct. All right, just remember, if x goes to the left or to the negative, y is going positive, and x goes positive, y is going negative in that case.